Um, okay, so good day, everyone. Okay, so for our first example, we'll try solving this one. Okay, this example. So, 5.2. Okay, this is from Andrew Paitel and John Q. Salaas. Okay, second edition. Okay, so the magnitude of the bending moment acting on circular cross-section of a beam is M is equal to 30,000 libra-foot. Okay, calculate the bending stresses of the following points on the cross-section. Okay, given A, okay, A, B, and C, and for C, it's D. Okay, so these are the points that we are going to look upon. Okay, so we'll find the bending stress at point A, point B, and then point D. Okay, so without further ado, we'll try solving it. Okay, by using pen and uh, paper and calculator. Okay, so we'll try this one. Okay, so please consider this. Okay, so I have just uh, copied, and then from the figure I tried to, okay, from 5.2 I just tried to get the cross section area. Okay, so that um, we will not waste too much time. Okay, so this is actually a 3D, so I make it in 2D. Okay, so this form. Okay, so first what we are going to do is to find uh, the bending stress at A. Okay, so let us say A. Okay, so we solve bending stress at A. Okay, so looking upon the figure, okay, so we have, okay, so we have a moment that is clockwise. Okay, so so if the moment acting upon the cross section of your beam is clockwise, then okay, it's its stress diagram will be like this. So if, okay, so please take note that if counterclockwise, okay, so for clockwise, so since this is clockwise, so at the top, your top will be in tension, and your bottom, okay, your bottom will be in compression. Okay, so that is if your moment is clockwise. So if it is in counterclockwise, it is the other way around. Your top will be in compression and your bottom will be in tension. Okay, so that is how it is. Okay, so since point A is located at the top, so therefore it will be automatically in tension. Okay, so there are two ways in order to solve this, but I prefer to use this formula. Okay, so let us say stress at A is equivalent to MC over I. Okay, so here our I, our C is equivalent to, since this is 8 inches, so therefore this portion will be 4 inch, and then this will be 4 inch also. Okay, so since it is a circular and is asymmetric, whether you look at z-axis or y-axis, so therefore your C, so this, your 4 inches will be your C top, and your another 4 inches will be your C bottom. Okay, So after that, we can compute already our stress at A. Okay? So our M is logically 30,000 libra foot. Okay? Okay. So 30,000 libra foot. Okay? In order, we multiply it by 12 inch per 1 foot so that it will be, we will have a uniform unit of only libra and inches. Okay? And then we have C-top. Our C-top is, since A is located at the top, so our C-top, our C is will be 4 inch. We will use the C at the top. Okay? And then our I is equivalent to, the formula is actually pi over 4 times R, okay? Big R to the fourth minus small r to the fourth. Our big R here is, okay? Our big R here is 8 divided 2, so it will be 4 to the power of 4. And then the small r, obviously, is 6 inch divided 2, okay? So 3 to the power of 4, okay? So we use a calculator, okay? So it will result to 10,476.940 libra per inch squared. Oh. Libra per inch squared is also denoted as PSI. So we can say 10,496 10,476.943 PSI. Okay? We can actually convert that into KSI. So it will become 10, okay? You divide it by 1,000 so that it will become KSI. So 10 point, okay, to 3 decimal place, 10.477 KSI. Okay? So this is your bending stress at A. Okay? And then, how about your bending stress at B? Okay. So your bending stress at B, okay? So I will our answer is lacking. So because it is at the top, and then for if it is acted upon by clockwise uh, clockwise movement, so your top will be in tension. Since A is located at the at the top, so this will be 10.477 KSI tension. Okay. Okay. So I'm sorry. I have I have a very shaky hand. Okay. So bending stress at B. So stress at B is equivalent to MC over I. So here, our C is the C bottom. Okay, so because it is located downward. Okay, but somehow our our C here, okay, more likely we use Y since it is not the maximum bending moment. So we use MY. Okay, MY. And this Y is equivalent to, okay, obviously 6 divided 2 because it is located in the inner part. So y is equal to 6 over 2 is equal to 3. So therefore, our M is the same, 30,000 libra foot, okay, times 12 inch over 1 foot times 3 inch, okay, the Y, over pi over 4 times 4 to the power of 4 minus 3 to the power of 4. Okay, so what our answer will be 7,857 0.707, since this is inch foot, so it will become PSI, or it is equivalent to 7.858 KSI. Okay, so since it is located, your B is located at the bottom, and it is acted upon by a clockwise moment, so it will be in compression. Okay, so here we have at the end. Okay, so we will find the value at D. Okay, so D is located. Okay, so let's clarify. So it is located 60 degrees. Okay, 60 degrees. So it makes 60 degrees with horizontal. Okay, so since your D makes 60 degrees with horizontal, okay, so your bending stress, okay, let us at D. Okay, so stress at D is equal to my over I. So your y here, okay, is this from your z axis up to this point. Okay, this is your A and this is your D. Okay, so your y will be automatically will become 4 sine 60. Okay, so that is what we do. Okay, so your M, the same, 30,000 libra foot. Then we multiply by 12 inch over 1 foot. Okay, to convert it into libra inch, times, okay, the y, which is 4 sine 60, over pi over 4 to 4 to the 4th minus 3 to the 4th. Okay. So we have 9,073 0.298 psi, or this is equivalent to, okay, 9.073, okay, KSI. So this is your stress at D. And since it is located at the top and then it is clockwise, so it's in tension. So this is tension. Okay, so these are your answers. Stress at A is 10.477 KSI, tension. Then we have stress at P is equivalent to 7.858 KSI, compression. And finally, we have stress at D is equivalent to 9.073 KSI in tension also. Okay, so let's recap our solution. Okay, from top to bottom. So this is our question and this is our solutions. Okay, so I hope you will understand. You understand our lessons. Okay, and also this is a 5.2, the question, the question